Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the first module of this course, that is the introduction module. And the idea behind this module is to give you a basic introduction to operating systems. So within this module, currently we are on the third topic, that is the compute stack. So in the previous video, we discussed what is a compute stack. We saw that a computer system can be thought of as a stack of different layers, and we talked about what are those layers. So now in this video, from this video onwards, we are going to look at these individual layers one by one. So let us start from the very bottom. So at the very bottom of the compute stack, we have the hardware. So in this video, we will touch upon the computer hardware. So we have already talked about computer hardware in the first topic in great detail. So in this video, we will just summarize what we have learned in that topic and basically summarize our learnings for that layer, the bottommost layer, the computer hardware. So without further ado, let's get started. So this is the compute stack that we introduced in the previous video. So as you can see, at the very bottom, the first layer is the computer hardware, right? So this is the first layer from the bottom in the compute stack. And then this is the hardware interface that is exposed to the layers of software that run on the hardware. So what makes up the hardware? This diagram basically shows you. So the computer system consists of three major components. First is the CPU or the processor. Second is the memory. And then we have a set of IO devices. And all of these components are connected by the interconnection system, that is the bus. So basically the computer hardware consists of the physical objects, the CPU, memory, IO devices. These are the electronic chips, the boards, the devices, right? So this is what makes up the computer hardware. So as you can see, these are the major components in computer hardware, the CPU, memory, and IO devices. So what we will do now, we will take each of these hardware components one by one and quickly recall what is their major role, how are they organized, and what is the interface that each of these exposes to the layer of softwares above, right? So we'll start with the CPU first. So this is how the CPU looks like. So what is the fundamental job of the CPU? The fundamental role of the CPU in the computer system is to execute instructions. So the way this works is that the user gives their input via the input devices, and that input goes into the memory, and the memory contains two types of information. First is the data that the user wants the computer to process for them, and then there are a set of instructions in the form of a computer program. So what the CPU does is that it fetches that data and the instructions and basically executes those instructions one by one in order to manipulate that input data, and in this way it produces some new data which is sent as output to the user for consumption. So this is how the basic processing happens, and in this basic processing, the CPU, its major function is to execute the instructions. So let us now discuss the major components in the CPU. So there are two major components in the CPU. The first is the registers, and then the second is the execution circuit. So the registers are basically a form of high-speed storage. So when the processor fetches the instructions and data from the memory, they are stored in the registers. Basically, these registers are very high-speed storage that can keep up with the speed of execution of instructions. So basically, a modern computer system has the capability to execute millions and billions of instructions per second, and these registers are designed to keep up with that speed, right? So the basic function of the registers is to store the input instructions, input operands, and after the CPU has produced some data, some output data, those temporary results are also stored in the registers. So now you can see there are two types of registers. First is the general purpose registers, and then there are the special purpose registers. So general purpose registers are used by the CPU during the execution. As I said, they store the operands, instructions, and temporary results that are produced by the CPU. And then there are these special purpose registers which have a dedicated use, and some examples are the program counter, instruction register, stack pointer, and program status word. So the program counter basically stores the address of the next instruction that has to be executed. Similarly, the instruction register stores the current instruction that is being executed. This stack pointer stores the top of stack, has a pointer to the top of stack, and stack is a memory region that is used for the execution of functions. And finally, this program status word is a collection of flags. Each of these flags basically displays some status that is related to the execution of the program. There are many more special purpose registers, but these four basically give you a basic idea of how these registers work. So this was about the registers, and then we have the execution circuit. So basically everything that is involved in the execution, that comes under this execution circuit. So execution circuit will basically contain a lot of units with a lot of functionalities. Here I have only shown two units, just to give you a basic idea of what can constitute the execution circuit. So everything in the CPU apart from the storage registers lies under the execution circuit. So first let's discuss about the ALU. The ALU is a basically arithmetic and logic unit, and as the name suggests, it takes in some operands and does some arithmetic and logic operations like addition, subtraction, division, multiplication. And logic operations examples are and, or, not, and it takes some operands and combines them in some way to produce a new value. So this is the core computation unit in the CPU. There are many more functional units like the ALU that are involved in the execution of the program. And then there is this control unit. So the control unit is like the nervous system of the computer. So it decodes the instruction that is currently being executed. It figures out the operands and the operation that has to be performed, and accordingly generates a lot of signals, control signals, that are meant to basically control all the other units. So this is like the nervous system. As I said, it generates a lot of control signals that orchestrates all the other units. So this is like an orchestration unit for the for controlling the behavior of the CPU. So this was about the CPU, what are the major components and how does the CPU work in brief, right? So now let us discuss the interface that is exposed by the CPU to the layer of software that runs above it, that is the operating system. So from the operating system's point of view, the execution circuit is not visible. All the operating system can see is this set of registers. So the operating system can communicate with the CPU by reading or writing these registers. It is oblivious to the execution circuit that is there. Basically, it is not aware how the execution happens. It is only it can only view the registers. So this figure basically displays how. So this is the CPU, and this is how the CPU looks like to the layers of software above. So from the operating system's point of view, this CPU is just a set of registers, and the operating system can read or write some of these registers to communicate with the CPU, right? So this was about the CPU. Now let's look at the next hardware component, that is the memory. So now let us talk about the second hardware component, that is the memory. So this is how the memory looks like. Basically, the memory is a sequence of bytes or an array of bytes, and each byte has a unique address. So this is a simple 8-byte memory, and you can see the addresses start from 0 and go till 7. So these addresses are continuous in nature. Basically, there are no gaps in these addresses. And the whole purpose of the memory is to store instructions and data till the CPU is processing them. So basically, we as users give information as input via the input devices, and that information goes and sits into the memory. And the contents of the memory are of two types. First is the data. Data could be text, or it could be image, it could be audio or video. So it could have any format that we want the computer to process for us. And then along with the data, there are instructions in the form of a computer program which the CPU executes to process that input data. So after the CPU has processed, it produces some output data that is also stored in the memory till it is sent to the output devices for the consumption of the user. So the purpose of the memory is to store the instructions and the data till the CPU is processing them, right? And there are two ways to interact with the memory. One is via reading and the other is via writing. So we can read a particular address and get the data that is present in that location. So for example, if I say read from address 4, then we will get the data 15. And the other interaction with the memory is that of a write. So we can say write 56 to address 3. So then the data 56 will come and it will be stored here. So read is also known as loads and write is also known as stores. So reading and writing or loading and storing are equivalent. So these are the two ways in which we can interact with the memory. Another important point is that from the memory's perspective, it only sees a stream of addresses and data. It does not know from where the addresses are being generated, from which program this data is coming, from which input device this data is coming, right? So it is not concerned with the source of instructions and data. It does not know how these data and instructions are generated. From the perspective of the memory, it only sees a stream of addresses and data, right? So it is neutral to the source of the instruction and data. So this is how the memory works, and this is how the memory interface looks like. So from the operating system's perspective, as we already know, this memory is a sequence of bytes, and each byte has a unique address. So this was about the memory. So now, after talking about CPU and memory, let us now look at the third major component, that is the IO devices. So this is how the IO devices are structured. So as we already know, there are two parts to an IO device. The first is the device itself, and then there is a device controller. So let us take the example of a keyboard to understand this. So this is the keyboard, this is the device, and then with this device we have an associated device controller. And the job of the device controller, the fundamental job of the controller, is to receive commands from the operating system and then drive the device. So its major function is to move data between the controller's local storage and the device, right? So now let us talk about the connections. There are two types of connections. The first is between the controller and the device. This is called the device port. So this is where the device will plug in. So as you can see, the wire leading from the keyboard, it has a USB cable. This is a USB type cable, right? And this is a USB port. So this is where the device will plug in. And these device ports are at the periphery of the computer system. So this is the computer system, right? This part won't be visible to you, this part of the circuit. And at the periphery of the computer system, we have the device ports, where we plug in the device cables. And the other connection is between the bus and the controller. So this is the bus is where the device controller is connected with, and this is called the device controller interface. And this consists of a set of registers with which the operating system can communicate with the device controller. So basically the flow of operation is like this. Basically, first of all, there will be a status register, and the operating system will first read the status register to see whether the device is idle or is it busy. If the device is busy, then it will wait. If the device is idle, then it will give some commands to the device, right? Then after checking the status register, it will give some commands in the command registers. So for example, in this case, this is an input device, and the keyboard will be taking input from the user. So the operating system can give a command to the keyboard controller to read whatever data has been typed by the user, right? So this can be an example command. So after the command is given by the operating system in the command register, the keyboard controller begins their operation. So the keyboard controller will move the data between the keyboard and its local storage. And when the data has been transferred to its local storage, then it will do some post processing. After that, after the operation is complete, it will notify the operating system via the status register whether the operation was successful or some error has occurred. If some error has occurred, then that information will also be available in this set of registers. So this is how this set of registers acts as an interface for communication with the operating system. So from the operating system's perspective, the IO device is basically a collection of registers. Basically, the operating system never interacts with the device directly. It is always intermediated by the device controller, and within the device controller, the operating system interacts with the interface, which is this set of registers. So this is how the hardware interface for IO devices looks like. So these are the IO devices, and from the operating system's perspective, an IO device appears as a set of registers that are present in the device controller interface. And this is for one IO device. Since we have multiple IO devices in the system, so there will be multiple sets of registers. So this was about the IO devices, how they function and how does their interface look like. So now we have discussed all the major components in the computer hardware. We talked about the CPU, the memory, and the IO devices. We understood how all of these functions and what is the hardware interface that is exposed by these hardware components. So this picture summarizes the hardware interface. So basically the CPU appears as a set of registers to the operating systems, and the operating system can read or write these registers to communicate with the CPU. And the point is that the execution circuit of the CPU is not visible to the operating system. It only sees the registers. Then when we talk about the memory, So from the operating system's perspective, the memory is a sequence of bytes, and each byte has a unique address, and the operating system can read a particular address to get the data, or it can write some data to a particular address. So this was about the memory. And finally, about the IO devices. So there are multiple IO devices in the system, and each IO device appears as a set of registers to the operating system. Why? Because the operating system never communicates directly with the device. So there is the device controller that sits between the operating system and the device and intermediates the operation. And every device controller has an interface that is called the device controller interface, which is constituted by the set of registers, and the operating system reads or writes these registers to get the status, the command, or the status of the operation. This is how the operating system communicates with the device via the device controller interface. So this is how the hardware interface looks like. So once we have the hardware interface, now the operating system can work with this hardware interface and simplify this. So in the next video, we will talk about the operating system and how does it simplify the hardware interface. So this was it for this video. We are done with the first layer, the bottommost layer in the compute stack. So guys, that was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.